Okay, so picture the most terrifying thing in the universe. Something that literally eats light for breakfast and could rip you apart atom by atom. I'm talking about black holes, obviously. Now, what if I told you that these cosmic nightmares are actually dying? Yeah, you heard that right. The universe's ultimate predators are slowly killing themselves. And the reason why is so weird, it sounds like science fiction. But it's not, it's real. And it's called Hawking radiation. Stick around because this is about to get absolutely wild. All right, let's get on the same page here. Black holes form when absolutely massive stars, and I mean at least 20 times bigger than our sun, basically run out of juice. Without that constant nuclear explosion pushing outward, gravity just goes nope and crushes everything down to a single point. And when I say single point, I mean it. All that mass compressed into literally zero volume. Scientists call this a singularity, which is just a fancy way of saying we have no idea what's happening here. But here's where it gets insane. The gravity around this thing is so intense that it creates what we call an event horizon. Cross that line and you're done. Game over. No respawns. Even light, the fastest thing we know of, can't escape once it's past that point. And if you somehow found yourself falling in, well, the difference in gravitational pull between your head and your feet would stretch you out like a piece of spaghetti. Scientists literally call this spaghettification, which is both hilarious and terrifying. So, for the longest time, everyone thought black holes were basically cosmic trash compactors that would eventually eat everything in the universe. But then this guy named Stephen Hawking had to come along and ruin everything we thought we knew. So, Stephen Hawking, and yes, he's the guy with the robot voice from all those documentaries, was not someone you'd expect to revolutionize physics. The man was diagnosed with ALS at 21 and given 2 years to live. Instead, he said, hold my beer, and lived for another 55 years, while completely changing how we understand the universe. In the 1970s, Hawking was basically that friend who won't let sleeping dogs lie. He decided to ask the question, what happens when you force Einstein's relativity and quantum mechanics to work together? These two theories had been throwing punches at each other for decades, but nobody had really tried to make them play nice. The answer he found was so mind bending that it made other physicists question reality itself. Okay, here's where things get properly weird. You know how we think of empty space as being, well, empty? Yeah, that's completely wrong. According to quantum mechanics, empty space is actually buzzing with activity. It's like a cosmic foam where pairs of particles, matter and antimatter, are constantly popping into existence and then immediately destroying each other. This is happening everywhere, all the time, even in the space between your atoms right now. These are called virtual particles, and normally they're like the universe's best kept secret. They appear for such a tiny fraction of a second that they don't really affect anything. It's like they're playing the ultimate game of hide and seek with reality. But Hawking had a thought. What if these virtual particles showed up right at the edge of a black hole? What then? Picture this scene. A pair of virtual particles pops into existence right at the event horizon of a black hole. In normal space, these two would find each other in nanoseconds and cancel out. But near a black hole, the gravitational field is so intense that it can actually rip these partners apart. One particle gets yanked past the event horizon and disappears forever, but the other one, it escapes into space and becomes real. This escaping particle is Hawking radiation, and it's absolutely breaking the rules as we know them. But here's the kicker, the universe is really strict about its accounting. Energy can't just appear from nowhere. So when that particle escapes, the black hole has to pay for it. It loses a tiny bit of mass every single time this happens. So these supposedly indestructible cosmic monsters are actually slowly evaporating themselves to death, one particle at a time. It's like they're committing suicide in the most scientifically beautiful way possible. Now, get ready for this because it's going to mess with your head. You'd think bigger black holes would be hotter and die faster, right? Wrong. It's completely backwards. A black hole with the mass of our sun would be colder than the space around it. We're talking 60 billionths of a degree above absolute zero. These things are actually growing because they're absorbing more radiation from space than they're giving off. But a black hole the size of a mountain, that boy would be white hot, billions of degrees, and would explode in a matter of seconds. The rule is simple: the smaller the black hole, the hotter it gets and the faster it dies. It's like the universe's most twisted fever dream. Hawking's discovery created what might be the biggest
Oh my
oh
gosh,
crap
did you hear
moment
that?
in physics. It's called the information paradox, and it's basically this: what happens to information when it falls into a black hole? Here's the deal: quantum mechanics has one golden rule: information can never be completely destroyed. It can be scrambled, hidden, or transformed beyond recognition, but it can never just disappear. But Hawking radiation looks completely random. It's like the black hole is just spitting out white noise with no memory of what went in. So when a black hole completely evaporates, where does all that information go? Does it just vanish, breaking one of the fundamental laws of physics? Or is it somehow hidden in the radiation in ways we're too dumb to figure out? This paradox has been giving physicists existential crises for 50 years. It's like finding out that 2 plus 2 might not equal 4 after all. So here's the frustrating part: nobody has actually detected Hawking radiation yet. The signal from real black holes is so incredibly weak that you'd need to wait longer than the age of the universe to see even a single photon. It's like trying to hear a whisper during a rock concert while standing on the other side of the galaxy. But scientists are nothing if not stubborn. They're getting creative with gravitational wave detectors, studying the last moments of black hole collisions, and even making artificial black holes in labs using sound waves and special fluids. Some researchers are building sonic black holes that trap sound waves instead of light, hoping they'll behave similarly to the real thing. It's like making a scale model of the universe's most extreme physics. Hawking radiation isn't just a cool fact about black holes, it's a glimpse into the deepest workings of reality itself. It's showing us that our two best theories of physics are trying to tell us something important, and we're just starting to listen. Black holes have gone from being cosmic dead ends to being laboratories for the most extreme physics imaginable. They're like nature's particle accelerators, pushing the boundaries of what we thought was possible. As our technology gets better and our theories get weirder, we're getting closer to understanding whether Hawking was right and what his discovery really means for everything we think we know about the universe. So, next time you're having an existential crisis at 2 a.m., remember this: even the most powerful and terrifying objects in the universe aren't forever. They're slowly giving themselves back to the cosmos, one quantum particle at a time. The universe is way weirder and more beautiful than we ever imagined, and honestly, we're just getting started figuring it out. If this broke your brain as much as it broke mine, smash that subscribe button because there's so much more cosmic weirdness where this came from. See you soon.